From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 540. In this episode, Scott talks with Stephanie Hurlburt about creating a new GPU Texture Compressor.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. And today I'm talking with Stephanie Hurlburt. She's the owner of Binomial, and she's creating a new piece of software, a GPU Texture Transcoding, a texture compressor. Is that correct?
That is correct, yes.
So there's a market for this, right? Like you're saying that not only are you making a texture compressor, but that you're going to make like the best one, right?
Absolutely. At least the best one for a lot of use cases that I'm seeing.
Okay. So let's back up. What is a GPU lossy texture compressor?
There's a lot of words in there. The GPU is your graphics processing unit on a computer. Because graphics are processed in such a special way and such a common use case, hardware developers created the GPU, which is structured in such a way that it's specialized for drawing graphics. Lossy means that it's okay to lose a little bit of data. If we can take a photo of your cat and make it really, really small so that you can store lots of photos of your cat on your computer, it might be worth it if it's not perfect image quality. It's okay to lose a little bit. And then texture just refers to images, photos, pieces of 2D artwork, any kind of image or drawing that you can save on your computer. And then the compressor part, of course, is compressing it, making that data smaller.
Okay. So if I go and open up like Skyrim and I'm walking around on a cobblestone floor, is the texture, the photographs or the drawings of the art of that cobblestone? Absolutely.
So that cobblestone floor, it's probably a tiled texture, meaning it's a texture that repeats itself over and over. But if that texture was too small, you would notice the repeating and it would look really bad. So it's beneficial for the artist to make it as detailed and as big as possible. And that means that you probably should compress it a little bit to make it easier to store so you can have lots of different kinds of textures and not a game with just cobblestone floors.
And are these things like big, like 3 megapixel type photographs, or what's a typical texture size? I assume that they have round numbers, like 512 by 512.
Absolutely. And it really depends on games. A lot of, and actually it goes outside of games too. You know, think about Google Maps and all the textures that are needed for an application like that, for instance. But a typical game will have, you're right in that it's 512 or, 1K, 2K textures. Those are the common sizes that we see. It's starting to become more common to have 4K textures as well because your screens are increasing in resolution and people really want to use that to full advantage.
But hang on though, 4K by 4K, that's like what is that? 3 megapixels, 4 megapixels? That's like a photograph, right? That's a lot.
It's huge. It's huge. And that is exactly why, that and many other reasons are why a lot of people are looking at our texture compressor and realizing, wait, we really need to focus on compression and getting the best compressor we can. To give you an example, basically, a lot of GPUs have hardware decoding in them. So what that means is memory is very precious on a GPU. You don't want to store uncompressed textures on your graphics processing unit. So what they do is they store it in a special GPU format. We call these, they're different per GPU manufacturer. One example is DXT, another is PVRTC that you can look up. And basically, if you store it in that special texture format, you can decode it using the GPU hardware, which makes it really fast and it's stored in a way that the GPU likes. The problem with that is that a format like JPEG is a fourth of the size of those special GPU formats. So when you think about, dealing with a 4K or a 2K or 1K texture, if you have a lot of them, a fourth of the size makes a huge difference. And we don't want to unnecessarily store a huge texture, even if it can be easily decoded by our GPU.
And we're talking about big things here, if I understand correctly. Like I just downloaded, while we were talking, a wallpaper that was 4K by 4K. It was 8 megabytes as a JPEG, and I'm sure 50 or 60 as a bitmap. That's massive.
It's massive. And think about it. It was 8K as a JPEG. If we had stored it in one of these GPU formats, it would have been 4 times that size. That's crazy. That's not practical.
That seems like when we move into 4K gaming, we're going to hit a problem where Blu-rays aren't big enough. Like we're going to be looking at 100 gigabyte games. And as you move around these worlds, we're going to be transferring that information, from the solid state or the drive into the computer and then up into the GPU. Memory is going to be, there's going to be a lot of memory being used up in your GPU.
Exactly. And I mean, games always want to look as most cutting edge as possible. And a lot of that it involves taking advantage of high resolutions as well as using a lot of detail. A lot of new graphics techniques involve storing other kinds of detail in textures, like say light maps or normal maps or specular maps, which are basically extra textures that give you detail that you may not be able to deduce from just the photograph. So textures are on the rise, and what our compressor and transcoder does is it compresses your image to about the size of a JPEG. So think about that. Now it's a fourth of the size. And what it does is on the CPU, before it sends it to the GPU, it really quickly transcodes it into a format that the GPU can actually understand. DXT, PBRTC, one of these formats. And then you get to take advantage of the really fast decoding. So it basically allows you to store these images in a format that's much smaller, as well as transfer it to the format your GPU likes. So it's the best of both worlds is what we're trying to achieve anyway.
Okay, so let's back up a moment, because we've talked with a lot of words and a lot of assumptions that maybe the audience doesn't understand, and maybe I'm a little confused. So the creator of the texture works in Photoshop and whatever tools that they want to make, right? They may take photographs, they may render it, they may do whatever, but they make a source raw image of the highest possible quality. Is that right?
Yeah, exactly. So
that's their asset. Is that the word?
Yeah, they make their assets. So in your cobblestone example, I make a really beautiful cobblestone floor that will later be tiled into a game. What I do if we used our compressor is I would use the compressor to compress it into our special format.
At the time of game creation?
At the time of the asset creation. So we do this beforehand. Just like you would a JPEG. You store JPEGs on your computer. JPEG is a compressed format.
Okay.
Exactly.
So then I save that on my, in my, as I'm building my game. It's part of the build process. Just like as a blogger, I run, like tiny PNG or PNG gauntlet to squish my images before I upload them. The game maker goes and runs your closed source encoder and then encodes it in your format. What do they do now before the binomial system, before, Stephanie's machine, before Stephanie's creation? What did they do?
They can use a number of methods, and it's actually really fascinating to see the different hacks and techniques that people have come up with. So, there are a lot of game studios that will save it to something like a JPEG, for instance, because that's really small. We love that. And they still understand the importance of storing it in these special GPU formats on the GPU. So what they'll do is they will save it to JPEG, and then they will decompress it entirely on the CPU and then recompress it to one of these GPU formats. So that not only will take them extra time because you have to decompress it and recompress it, but it'll also add double artifacts. JPEG introduces different artifacts than these GPU formats do. And so when you decompress it and recompress it, you lose even more detail than you should. What our transcoder does in comparison is takes the compressed format and transcodes it, which means there's no decoding and re-encoding stage. It turns it directly into the compressed GPU format, which is much better for quality and speed.
And space, right? And you get the same space that you had with JPEG.
Exactly. And the other thing that I've seen people do is they'll just store it in the GPU format from the start and say, I guess I will either try to compress that with something like zip, or just a compressor, and then decompress it right before I get to the GPU and take whatever losses that gives me. Or I'll just accept the fact that it's 4 times the size it should be and apologize to my users, because at least it's directly in the format the GPU will understand, and I won't need to worry about any decompression and recompression.
Is decompression expensive, or does it depend on the kind of decompression?
It definitely, of course, depends on the kind of decompression you're dealing with. But for this particular case, it is more expensive than transcoding, for instance. Our transcoder is faster than decompressing an image and recompressing it.
What is the distinction there when you say transcoder? Like when I think decompress, like I read the bits off the disk and I explode them and then I put them back on the disk and then I say, hey, there's the file in temp space or whatever. Is transcoding just decompressing into memory, or is it a more different definition?
That's an excellent question. So when you decompress something, you basically explode the bits, as you say, but you also turn it into an image that you can actually see and read on your computer. When you transcode it to another compressed format. So imagine taking a JPEG and turning it into a PNG, just directly. Like it's the process of going from one compressed format to another.
I see. Without decompressing.
Without decompressing.
It didn't explode and then sit in memory as a big buffer and then squish.
Exactly.
So it's more efficient.
It was squished, and we just rearranged the bits so that it's squished in a different way now. No intermediate step.
Okay. So to put it into like techie layman terms, I could, unzip a file. I could unzip a zip and then use RAR and RAR it up again, but I'm going to need all that space in memory and all of the churning to go and do that work. If I could just tell the zip, make me a RAR, and it never got exploded, that would provide me all sorts of value. It churned less on the disk, CPU works less, everybody wins.
Exactly. That's actually a perfect example. And let's imagine a case where RAR was so much bigger than the zip, but that's what you needed to end up with. So our case would be like taking the zip, which is this tiny format, but not something usable in the end, and transcoding it directly to that RAR only when it's needed, when it's about to send to the GPU, except not with zip and RAR.
So putting this into like topical terms, did you see the Dropbox announcement yesterday?
I must have missed it. I was out of town yesterday. You must update me with this announcement. So
let me see if I understand this, because you're the expert. They came up with a thing. They just released an open source image compression format called Lepton. So, right, Dropbox knows that we all have JPEGs in our Dropboxes. So they will take and they will compress JPEGs, and they can compress them at 5 megabytes a second, and they can decode them back into the original bits at 15 megabytes a second. So basically, they've made 22% savings reductions for existing JPEGs. They've gone through our Dropboxes, squished everything into their format called Lepton, but it's lossless. And then when we request our JPEGs, they stream decode it, they transcode it back into JPEG, and we don't notice the difference. Yes, that's so similar. The only difference is that the compressor that we're making will be lossy, but we hope that it will be lossy in such a way that it doesn't really affect your quality in a way that you'll notice. Right. The way that modern JPEGing is, like if you set your JPEG at 90, you have to be a photographer to notice that the sky has artifacts.
Exactly. And what we determined is that lossiness is worth it for the speed and the compression that you get. But I think it's amazing that Lepton is lossy and transcodes and saves you so much time and space. That's really awesome of them. I love seeing new compressors in this space.
Yeah, it's lossless, and they're doing it, of course, to save money. And you're doing it to not only make it better for the gamer, make it better for the developer, but in such a way that it sounds like it's just everybody wins. It's just a superior way. No one loses in your scenario.
Exactly. And it's really fascinating to me to think about it beyond games too. Like I got a call from someone in the medical industry the other day who was saying that this would really change the healthcare industry in terms of sending X-ray scans, CT scans for prognosis, videos through their network, all kinds of things. So, I mean, think about the amount of ways that streaming image data affects our lives through all industries. It's extremely important to try to do it well.
Had you thought of that? The healthcare idea?
No. Someone reached out to me directly. I was surprised, and I welcome input like that.
Wow. Okay. So let's dig a little bit into how the GPUs work. I hear about, a new GPU comes out every 6 to 9 months. And then I read on like Anon to Tech, all these things I don't understand. And suddenly we're in a scenario where it feels to me like the video card, the $600 video card you can buy is as a good of a CPU and a computer as my computer is. It's got 4 gigs of RAM and it's got, 8 processors. Is that card that I put into my desktop as powerful as my desktop?
It is very powerful. And what's fascinating about your question is it's just powerful in a different way. So one of the easiest ways to explain that is to talk about multi-threading and doing things in parallel. So on your CPU, you don't have nearly as much ability to parallelize your work as you do on your GPU. However, there are other advantages to your CPU. You have a lot more memory. It's structured in a way that's better for certain processes. GPU is really good at doing simple actions all at the same time. And that makes sense, right? Because when we process graphics, we want to be doing operations on all the pixels in our screen. Seriously, every pixel gets processed by your graphics. And we can't do that on 4 threads. Think about how many pixels, especially modern screens, have. So the GPU is able to highly, highly parallelize those operations. The downside is that as GPUs have gotten more powerful in some ways, memory is still a big concern for GPUs. Everything still starts on the CPU and is sent over, and the GPU is not great at dealing with large memory loads, which is partly why focusing on compression and doing that very well is so important.
Why can't we just put 16 gigs of RAM on a video card and load the whole game in, or 32 gigs? Isn't memory so cheap now? I mean, they have these giant fans and they've got all these processors. Why not just throw, gigs and gigs of memory at the problem?
That's actually an extremely good question, and it's up to the GPU manufacturers. Maybe they should work on making that a bigger priority, but I imagine, I'm not a GPU manufacturer, but I imagine that there are a lot of things to consider. For instance, actually building memory into the GPU might be harder than we think. And the other amount is, the more memory you put, the more you have to think about, well, if I just make all of this memory equally easily accessible, I'm going to overall slow down my memory access. The concept of caches, for instance. I want some memory that's really easily accessible. So they would have to, as they put more memory on a GPU, they'd have to think about those problems some more and design it in a way so that memory access is still really fast. It's a very complex issue, but I agree that more memory should be on GPUs, and we should be solving that problem as well.
Yeah. So there's this new NVIDIA card called the 1080.
I'm so excited. Yes.
Yeah, that's like the one that we all want, right? It's like $600 though or something. It's ridiculous. in the list of all of the huge numbers of things that it has 160 texture units. What does that mean?
That's a really good question, and I need to dig into the specs of the 1080 in detail. I haven't yet, but I imagine those are the units that I was discussing that process texture data in parallel. So it allows that GPU to be even more parallel than the GPUs that were prior, which is fantastic. So that's what we want.
This is a logical unit that you use, a texture mapping unit for once you've decompressed your texture. It's the thing that rotates it and moves it around and does stuff with it, right?
It puts it does in 3D stuff space. With it. Exactly.
Okay. So then they will take your transcoder's resulting textures and then spin them around and do stuff with them and then put them on the floor and I walk on it.
Exactly.
Okay.
It's really fascinating. This might be a tidbit that isn't necessary, but GPUs work in a very tile-based approach. So what they do is when I access a pixel on your cobblestone floor, for instance, I want to turn that pixel yellow because the sun is shining on it. And it's really important that that cobblestone floor reflects the sun in a good way. So I would grab the pixel, but instead of grabbing the entire image, I would just grab a small tile of the image to work with. And that's one of the things that these GPU formats and GPU hardware architectures really good at, and that helps with saving memory, is only accessing things in tiles instead of always needing to grab the entire image to memory.
And now your partner in crime here at Binomial is Rich Geldrick?
Yeah.
And is the name of it is Crunch, is that correct?
Yeah, so he previously worked on a free and open source library that anyone can use now, called Crunch, that essentially does everything most of the things I've been telling you our compressor will do. It hasn't been actively maintained and worked on for a few years, and we have just been talking nonstop about all kinds of ways to improve it, and also the fact that it only handles certain GPU formats. For instance, if you wanted to make an iPhone game, you couldn't use Crunch because it doesn't support that kind of GPU format. So we were thinking it's really important to get this technology in the hands of everyone, so that if you're not on a Windows PC, you can still use this in your game. I think that's extremely important.
Okay, so then your encoder will take the formats that the asset creator is making and then hold them, and then the transcoder will detect and figure out or be told that you're on an NVIDIA, you're on an ATI, you're on an iPhone, you're on an NVIDIA Shield or whatever, and do the right thing that is optimal for your GPU.
That's the basic idea behind it, and that'll make it so that you don't need to use tech that's not as good if you're developing as an iPhone game. This really is, for this particular use case, moving texture data and displaying on the GPU. I actually don't know of a better solution, and I don't want people who develop on different platforms to miss out on it.
So what's the time frame for this? Is this something that's like Doom? You'll release it when it's done?
In general, but we do have constraints. Right now, we're a company that's kind of bootstrapping ourselves and funding ourselves with part-time contract work. We do VR and AR consulting and graphics consulting, primarily focused on optimization because it's really similar to this compressor work. But that takes up time. So we're thinking if we continue to do part-time contracts, maybe we'll have an initial build end of year, early next, but it depends on how much time that takes. What we're working on now is if some companies need it early or if people just want to support development, we're taking pre-orders, and that'll allow us to actually focus on this and get it done sooner.
Very cool. So then people who are listening right now and may know that someone is interested in a technology like this can reach out at binomial.info and get in touch with you.
Absolutely. Absolutely. My email is stephanie@binomial.info. You can email me anytime.
Okay. So if you don't mind, I want to shift gears a little bit and I want to understand the kind of software engineering that you do juxtaposed with the kind that maybe I do or maybe our listeners do, because we all consider ourselves programmers, coders, hackers, engineers. Mm-hmm. But it seems like, in school, I hung a left and you hung a right, because this feels very math heavy, very, very technical, while it makes me feel like, as someone who's a web developer doing CSS and doing HTML, like text boxes over data just isn't simply as hard a problem as this. Does this mean that you have a background in advanced math?
What's fascinating about that is that Rich and I work on this together, and we have very different backgrounds. I started school in mathematics. I wanted to be a mathematician, so math is definitely my thing. I love it. But Rich does not have a background in math at all, and has just kind of picked it up as he goes and focused on making smart architecture decisions and learning about algorithms and computer science instead. So there are many routes you can go, and having math is definitely very helpful, but it's certainly not something you can't pick up as well. And I actually encourage people to not be discouraged by a lack of math background.
Okay, so it is not like impossible for someone to shift gears. If I wanted to switch out of web, I know I have a background somewhat in, algorithms, and I can a reasonable amount of code smell. I can tell when something smells bad. What levels of math do I need to understand to start doing things in 3D space like this?
That is an extremely good question. And I would say basics in things like linear algebra are very good, because that is the mathematics of moving things in space, for instance. But and that's good advice for 3D graphics in general. But I would actually say, look up books like, I should look this up after so I can post it. But there are many good books focused around mathematics for game development. But moreover, I would not go into the field until you had a math background. I would dive in and start creating things, because the chances are you can build a lot of really, really interesting things before having a strong math background.
Really? That's very encouraging, because I can imagine that there are people listening who might say, well, shoot, I got to go to the Khan Academy now and I learned all about real coordinate spaces. And then that means 3 years from now, I'll be a graphics programmer. You're saying start now and do it all in parallel.
I would highly encourage you to start now. For instance, I got into the field through open source and free graphics engines like Cinder and Open Frameworks. And people who use those graphics engines, which are written in C++ and OpenGL, really low-level stuff, are typically artists. And it is so inspiring to see them just pick up these libraries. And if they don't know math, they'll Google it, but usually they can still build some really amazing things. And you can see more examples of artists using this kind of low-level tech on websites like GLSL Sandbox or Shader Toy. It's definitely something that I encourage everyone to go into, and you don't necessarily need years of school to pick up an example and start playing with it.
So you were a mathematician, you discovered open source software, and did you pick up coding, or were you doing math and computer science simultaneously?
I started school studying mathematics, and I ended up switching to computer science because I became really interested in visualizing my mathematics and building tools. And I ended up going into that way more than doing mathematics research itself. And then my first job out of college was working at an advertising firm that it was advertising, but it really kind of built art installations around the companies we worked for. For instance, they would design lobbies that had very interesting digital sculptures in there. And while building those, we had to get really low level because they were the types of art installations that weren't done before. So we had to make our own tools, and that required picking up low level graphics.
That gets me thinking about one of the most impressive things that I've seen in the real world, which is when they map a projection onto an existing building, and then they'll make the building blow up or whatever.
It's amazing. It's fascinating. And to me, one of the most inspiring things and why I like building graphics tools for people is building a tool for an artist that has never used math or programming before, but who has a very strong design sense and a very strong art background, and seeing what they're able to do with this amazing new medium we have. And that's why I'm always encouraging of people to try this out without needing a strong math background or a strong computer science. It's likely you can still build things.
Now, are you a gamer as well, or do you spend more time thinking about math than you do actually using your product?
I spend a lot of time thinking about math, but I do love games very much so.
So do we spend our time looking at your code on Binomial LLC? I know that you have part of it open source and part of it closed source, right? You're going to make the encoder closed, and that's how you'll make your money. Yes. And then the encoder will be open source and everyone can learn from it.
Absolutely. So our transcoder will be open source. The encoder will be closed source. But for now, you can go to Binomial LLC's GitHub and check out Rich's Crunch library. That is entirely open source, including the encoder. And it's a great way to see something similar to what we'll be making.
Very cool. Well, I really appreciate your time, and thanks so much for talking with me today.
Thank you. It was so nice to meet you.
Nice to meet you, too. This has been another episode of Hansel Minutes, and we'll see you again next week.